Okay. Good morning, students. I welcome you all on behalf of IACSD Akurdi and CDAC ACTS to the webinar on development operations by Mr. Arvind Kavre. He is the Principal Development Architect at Finastra. This webinar is being hosted by IACSD Akurdi, which is an ATC of CDAC ACTS, and we have been in existence for the last 20 years. And we have been nurturing and grooming students for the IT world. I would like to introduce and welcome the panel, Mr. Arvind Kavre. Good morning, Mr. Arvind.
Very good morning to you and all the students.
And good morning, Ms. Madhuri.
Sorry, good morning.
And good morning, Mr. Christo.
Good morning, everyone.
And students, welcome once again for this wonderful webinar, and I hope a lot of takeaways and technical insights will be shared, and then you are a better person technically and would be ready to lead your career in the IT industry. Or if you have already joined, there are a lot of takeaways. I would request Mr. Christo to take over and then introduce the panel members and the organization, and then how this webinar is going to unfold. Over to you, Mr. Christo.
Sure. Thank you. Thank you very much, Keshav sir. Happy to be back at CDAC because I have been coming to CDAC over the years. But yeah, coming virtually is the first time. And I hope, it is the same experience for everyone. So good morning, all. We are very happy to, have this session done for you. And I'm sure, many of you would have already hit and checked, what Finastra is about, or, what Arvind, who is this person who is going to talk, and done some research, checked his LinkedIn profile and did your bit. But, I would like to, probably give you some insights of what Finastra is to start with. Arvind, if you can just do the screen sharing and put the first slide, I think that will help.
So the screen is already shared. It says that one participant can share at a time.
Okay. I think they have removed the slide now, and you will.
Just hold on. I got it. Can you?
Yes, thank you very much. Yeah, all right. So we are from Finastra, and Finastra was formed in the year 2017 by the combination of two different organizations named MISYS and D+H. Finastra builds and deploys innovative next generation technology on our open fusion software architecture and cloud ecosystem. Our scale and geographical reach means that we can serve customers effectively regardless of their size or location, from global financial institutions to community banks and credit unions. We bring deep expertise and an unrivaled range of pre-integrated solutions spanning retail banking, transaction banking, lending, and treasury and capital markets. We have a global footprint with the broad set of financial software solutions available on the market. Finastra has 1.9 billion in revenues, 10,000 plus employees, and over 8,500 customers, which includes 90 of the top 100 banks globally. So, we are a global organization, and if you check out our website, you will really identify in terms of the kind of financial applications that we have and the impact that we have in the fintech space. So, that's about Finastra in a gist, and I'm sure you will get to know more throughout this webinar as Arvind will talk about in terms of, what we're doing in the DevOps space. Now coming to the presenter of this show, Mr. Arvind Kavre, and I would like to probably give you a gist about him. Arvind, if you can just go to the next slide, please. Arvind comes with 20 years of industry experience, working in various roles, ranging from being a developer, being a product owner, being a program manager, being an architect at companies such as Citi, Oracle, TCS, and now, for some time he's been working at Finastra. He's an engineer by heart. He still enjoys coding while defining the business value through technology. He has published 2 internal white papers for Finastra on containers and Ansible. In personal life, after returning from US, he is settled down in Pune with his wife and son. He likes reading history and autobiographies and listening to Bollywood music, like all of us. And he enjoys farming whenever he gets time. So that's in a gist about Arvind. And without further ado, I pass on the baton to Arvind to take the session. And today's topic for discussion is development operations. Over to you, Arvind.
Thanks, Christo. So it's a nice introduction. Good morning, everyone. Once again, thanks for this opportunity to talk to you here virtually. I would have loved to come visit campus and talk to you personally, but this is not bad scenario as well. So yes, common question, right? When we go and whenever some company visits our campus or someone senior comes, as a student, at least when I was student, I used to have always this question: whenever someone is visiting, what I'm going to gain basically from this individual? That is one. And second one is, how is it going to help me in my career path? What is my goal basically? So you are a CDAC student, graduation, you are doing PG or you already done PG. But the common question generally has it like, what is a career for me in software? Am I going to be a software developer? I want to do testing. Business analyst, what is this role? And then obviously, many of the seniors, yes, I want to be a project manager running the show, right? The responsibilities of taking care of the things. Programmer, someone always interested in, I don't want this managing people, look into, but I do want to hardcore programmer, basically, like ask anything. I'm a geek, basically, I'm a master. In C++, .NET, Java, these are the like opportunities. And then there are certain things, basically, like few individuals just think that like, I just want to be an IT job, basically, or maybe I will work for a BPO or any job, but it should be an IT, right? And then we look for institutes which guarantees the jobs, and then it lands us into these gig words, basically buzzwords, right? What is this maze, basically? Like, what do you mean by build, pipeline, cloud, microservices, service discovery, images, automation, containers? And we start thinking and visit and talk to our friends, and they start talking about, oh, there is a very good opportunity in this thing. This company is hiring in this domain. They're looking for CI/CD engineers. They're looking for pipeline expertise, and there is a role for cloud ops. So I hope that after today's session of the DevOps, probably like this maze probably I'll be able to handle, and you will know something about this one. So how do we proceed basically? So we will breeze through in this 1 hour session. We'll understand basically what is a product life cycle. Finastra being a product company, product life cycle is very important for us and for everyone basically. Like, so we'll go through that one. We'll understand what is a DevOps, how it moved from product moves from development to operations mode. What are the disciplines of DevOps ecosystem? Then world of continuous. You must be knowing like DevOps is something like something is happening continuously. Then we'll touch upon the key elements of DevOps like configuration management, where most of the automation and inputs from DevOps are required. Then the containers, which is a future, and how the containers flow. We'll touch a little bit on pipeline, and we'll try to understand what are the rules available among this from 1 to 9. What are those rules? And then we'll visit opportunities in Finastra. Sounds okay? Okay, so we'll quickly move on to the first slide. Basically, what is the product life cycle? Just give me a minute. My screen is getting mapped by something else. Okay, so what is the product life cycle, right? It's basically from requirements to run. If you look at it on the left side, it's a black box, requirements feature. And why it is black color? Because this is the only thing, right? We get from either our product experts, who are the product owners for an organization like Finastra, or if you're working for services organizations which are just doing the customization for products, like companies having tie-up for their customers, like insurance sector or banking sector, and they give us the requirements and we try to do all these things. This is one thing which is little gray. Requirements are never complete or never give you the complete view. But then based on whatever the requirements we get, we plan, we articulate what is required, come up with the program specifications, requirements. Then we go and start building, coding basically of that requirement. Do the build means like compile the code, ensure that like all database elements are checked into the database, code is completed, multiple developers who are checking in the code, working on that requirement will check in the code, it gets integrated. Then it moves into QA, where the testing is happening. The testing guys comes into this picture where the developers reduces and the testing increases. And at the end, basically like we are delivering it to customer, or we are saying like maybe we are delivering to operations, where operations deployed into the deploy this product into their UATs. UAT certifies, approves, and it goes into the production. And the last phase is basically run. So it is like development, test, deploy, and run. That's this basically the 4 words. From the buzzword point of view, and the keywords basically like which you need to remember is like plan, code, build, certify, release to the customer, which is delivered to the customer, and then deploy, and then operators and monitor. Because once you deploy to the various systems, you need to ensure that you are monitoring the system uptime, it's running smoothly, it is doing and adding value to the business, and it's doing maximum with maximum service availability. So what are the 2 models basically? Like what are the 2 methodologies? So few years back, if you look at it, the waterfall model was the only one available. It's very simple. Like you are defining the requirements, the first part, you are building it, and you are releasing it, and adding and delivering value to the end customer. It's happening in a turnkey project model where you're trying to gather all the requirements at this stage only. You are visualizing product, how it is going to be, multiple features, multiple things basically you are trying to imagine here and building it here. Here, for the project, the risk is less right now because you are still in the defining of requirements. Then it enters into the development phase where you are trying to write program specs, you are coding, you are trying to integrate the code, you are also testing it during this phase. Now, if you look at it, the risk is increasing because any changes now you want to do here, something if the requirement changes here, you have to go back and visit and start from here again. And the cost of doing it is a little bit higher too, right? Because now you have to start seeing what is the impact on the other models other developers have done. And at the end, you are releasing it to the customer. At this stage, if anything changes, you have to come back all the way here. And this project's waterfall models is to run for something from 2 months to 6 months cycle. Means you are trying to visualize work which is 6 months and how it is going to look like. And then that's where those jokes in IT you might have come across, like someone is asking to build a ladder and then what we are building basically, right? The jokes which we share. That's where the agile project model came into picture. What the agile model is very simple basically. Like what I am saying is don't eat too much in one go. Do it in chunks. Identify what is a high priority item and what are the low hanging fruits as well. What you can deliver quickly. Okay. Just focus on that, build on that one, and you plan, build, test, and deliver to the customer. Customer is testing, so you are getting early feedback. By that time, you are moving to the second requirement, and that's how you are going with the third requirement. So there are advantages of both the models and there are disadvantages of both the models. First thing is like in the first model, like it's very simple, easy to test. You are having a highest control here because you have PM, you have a product owner as a part of the team who is keeping the complete eye on the end-to-end cycle. He's looking at it, he's splitting your requirements in this one. So they are the ones basically who are visualizing the product, not the developers. Whereas from that point of view, this is little complex. Why? It requires a different vision. Instead of visualizing the complete product, you need to split your requirement and bulk portion. Like there might be a big module. You have to split that module to see what you can achieve in the first cycle, first iteration. What you can build on top of that in the second module. Will it have a conflict with the module which you are going to develop in the third stage? At the same time, whatever you are delivering here, it should add some value to your customer as well, right? Because otherwise you build something, you deliver to customer. If the customer cannot do anything with that module, then again it is not going to be fruitful, right? It is not going to add the value to the customer at this point. So it requires a little bit of vision. Everybody understands basically what they are delivering, and that's the advantage. Plus, the biggest advantage in the agile project is you are getting immediate feedback, because like you are delivering to customer, and if it is not as per the customer's expectations, right, where he's expecting a blue color button and if you are delivering it is a maybe a sky blue button, right? So he's saying, no, my theme is not matching. You are getting immediate feedback which you are correcting into the second iteration of this one. So that's these are the two models which are popular. Now look at it, this diagram, the one which we had in the first slide, and now this is how will this happen basically, irrespective of which module you choose, right? Is this that simple? Like you are planning, developing, what is additional things which we can do basically, right? So there are a lot of things when the developer is developing code. It's not like you are just giving him some saying that, okay, I need a code in Java, you develop it and do it. How can we make him efficient? And that's where the development engineering come into picture. Development engineering is not doing the development, but they define what can we do to expedite, to improve the experience of our developers, testers, operators, and the operations guys. So for example, if you are developing, you are using integrated development environment. So you need to, what development engineering does is like, it will ensure that you have all the add-ons in your development environment, so that when you're coding, it is checking everything. So for example, you are typing a code and it is not it's not going to be compilable, because like if you're adding a table name and column and it is not existing in database, that ID should give you warning there and there itself, and you should go and check it out, like, oh, table as DB has not created table. You will follow and then only you will process. Then there are other development tooling as well. Like if you're using a, let's say like you are stuck on certain function or the code which is very standard, right? Let's say like on-click function. You do a quick Google search and you find a better code from the net, and you want to use that one as it is. Open source, right? You copy that one into your module. It immediately tells you that, okay, it matches with something which is available on the net, which is different, someone else IP, intellectual property. It's not yours to use basically. That is number two. Let's assume that you download some software to help you to improvise your development experience, but that's not a licensed software. And therefore, like those are the tooling process is built by the development team, development engineering team for development. You move on to the next phase, which is certification, testing. Now, when you're going as a developer, when you're coding, you're not really bothered about like how my code is going to be functioning, what is going to be the performance, what is going to the code coverage. Means like, is there a condition I'm adding into my development phase that it will never get executed? For example, the value, let's say like I'm saying, if XYZ equal to 999, do this thing. But that XYZ 999 never happens, because on the screen, you are already controlling it by saying that the value should be alpha, alphabetical characters. It will not come, and the code will never get executed, right? So the code coverage basically. So all these things you cannot do when you are coding, and that's where it gets added into the QA testing phase. When QA team, which is doing the business function testing, the non-functional test suite kicks in here, which is developed by development engineering and does all the things for you. SAS, static code analysis, it runs performance, it does white source to check if you are using any open source, dynamic security, code coverage, and then at the end, it is packaging what you have developed. Moving on, development engineering plays a role, and a very important and big role here now, because the development, if you look at it here right now, So these are the developers, this is the IT support, and this is the DevOps team, basically, or development engineering team comes into picture, right? Here, mostly the developer's role ceases. It's just basically like developer is required only when there is a problem which you are having into delivery or deployment options. So here, provisioning of the infrastructure you required, like let's say like you're moving into UAT or you're production, or you need to create an environment. So provisioning happens here, configuration of your application when it's deployed, orchestration, you might have third party things, as well as having connections with your infrastructure. For example, like you might have the product might need some network access, different type of network access, that configuration, monitoring tools available in your infrastructure, right? So connections to those monitoring tools, performance, your disaster recovery. So those type of dev engineering functions happens here. And then when the product starts running, end user starts using this application, you need to ensure that like service availability is there, always no downtime of the product, monitoring, recovery if something goes wrong, like a service crashes because of some issue, there needs to be a standby service available, or a standby server too, right? If it falls, if it crashes for some any reason, like maybe a software reason or maybe a hardware reason. And then maintenance and support. At this point, if you see, these are the guys, right? They are doing the work which is completely oblivious to development team here. If you see here, the link between the development, which is developing the product, and the one which are operating, the bridge is basically the IT team or the DevOps team. So that's where like it moves from development to operations, which is achieved by development engineering team. Hope my speed is fine. And if I'm running fast, just raise your hand so that I can pause. Okay. So the DevOps, right? So we have seen on the left side, most of the functions were done by the development, and right side is basically operations. And that's where this DevOps team born. This new terminology came up into picture. Earlier, the terminology was very simple. Development, and it used to be like production support. But then there used to be a lot of gaps. Developer, as I shown in the previous slide, this development team has no visibility on how my product, which I'm building it here, is going to run here. What is the expectations here? But that visibility wasn't there. Similarly, these operations guys have no clue basically what mindset developer is developing this code. And therefore, the DevOps community came into picture to bridge this gap. Therefore, where it starts, like you plan, code, build, test, and then slowly the DevOps team is having a visibility on this part, because they're optimizing your experience here, ensuring that the problems which these operations guys are facing here are taken care of here itself already. The security gaps, performance, code coverage, redundancy, all those things are getting covered here. And then when it is deployed, they also help these guys to ensure that they understand what this product is looking for. What are the resource requirement for this product to operate efficiently? How many CPUs, how many services to be configured here? How many server nodes, disaster recovery needs to be configured here? All those things, and how this application can be monitored, because as a operators, they are not familiar with what you are developing. They are not understanding what is your business. So for example, I'll take the simple example of, let's say like Flipkart, right? Rather than instead of Flipkart, I will say Google Pay. You're trying to make a payment using Google Pay, right? And let's assume that Google Pay is having some problem, or maybe the capacity issues at any time, like maybe 100,000 users only can submit payments. And now you are the more than that, users are trying to make payment. It's a straight loss for Google, because what will you do is like you will try once, twice, and if it doesn't work, you will move to Paytm, or you will go to other payment platform to make that payment. It's a business loss for Google Pay. But then these guys are not aware of this thing. What do I monitor, right? So that's where DevOps teams help them with the knowledge they gathered from this development team. They help them to build monitoring that, oh, transactions failing, right? They get an alert and they will say, okay, we have more users, they're trying to make payments, and those transactions are failing. We need to increase our infrastructure, increase our capacity, increase our throughput of the transactions. And that's how those monitoring is enabled with the help of DevOps team, and then gets monitored. So this is the overall cycle of DevOps, which is very much closely aligned with our agile practices as well. So what is the role, what are the clear objectives of DevOps in product lifecycle, right? First one is improve the quality. Why? How it will improve the quality? Because now what you are having is DevOps team is having a clear-cut tooling done on the development streams. When the product is moving from different life cycle, it is ensuring that all the impediments are taken care of, like performance, high availability, configurability, what are the monitoring requirements, plus the code is getting continuously tested in the cycle, and then only you are getting certification from the QA or the business users frequently, and thus therefore you are reducing production incidents. Let's assume that, like you as I said, right, in the Google Pay, if you are not monitoring, you are not logging the error when 100,000 plus users start logging in and they're failing to process the transactions, that incident is not getting logged, production outage will happen, server will crash, and thus it will impact the overall business. It increases, another objective is the increase in the overall efficiency. It's not just like person dependence. You are documenting the best practice and saying that, guys, do this way. Do not use, when there are 10 options which we have to give the developers, use case statement, right? You're guiding him basically. But are we controlling it? Is there any way like to track and figure it out, unless you are doing manual check, saying that how many if statements that guy use? Probably not. It becomes manual dependency, and if someone skips that one, you are putting in that code into production straight away, right? But what DevOps facilitated is, as I showed in the previous slide, is you are putting in the tools and services there, which basically ensures that those are not manual person dependent, but these are process and tool independent. It increases the automation because we are putting the tools, we're going to code all those things. It reduces manual steps, reduce incomplete and conflicting requirements. As I said right in the beginning, like, as you are doing iterative process, if there is a conflict requirement you are doing, the tools will identify immediately and say like, okay, is this a circular requirement? It is conflicting with this requirement, or you are not addressing the actual business problem. There is no value addition at the end of the release, that iteration. It helps you to standardize the tools across. That is one of the objectives. So I'm saying someone wants to have a question. Yash Kumar, we can go ahead with the question if you have right now.
You can put your questions in the chat, and we can take it at the end.
Okay,
of the
sure.
discussion.
Okay, okay.
So anybody who has a question, you can put it in the chat section, and I will take a note of it, and we'll have those questions answered by Arvind at the end of the session.
Thanks, Christo. Okay, and then another objective, biggest objective is for DevOps is to integrate the tools with development and testing. Keep an eye on the production, how the production is going to run and operate, but at the end, ensure that like that tooling, their requirement is tooling and integrated with the development in such a way that those requirements gets addressed by these tools itself. And at the end, improve the overall performance. You are improving the system's performance, you are improving the individual's performance because they're using the tools, and overall everyone's performance gets improved and is a great team basically. So these are the objectives for the DevOps in PLC. So what are the DevOps discipline? Where DevOps plays a bigger role and important role basically, and how do you improve this? So first thing is version control. Earlier in the waterfall model or the earlier processes of the version control tools, at any point of time, only one developer could check out the file and work on it. Now, if that file or that code file is required, program is required by 2 developers, it wasn't allowing you to do that one. So this guy will check in the code, you wait for that one, then you work on that file. And you, both of you are completely unaware of that your requirements, your code itself is conflicting with each other until you are doing the compilation or testing the code. So, but the latest of the tools with the DevOps, what we are doing is it allows you basically to do parallel check-in. So same file, 2 people can operate on that one, check in the code. Version control tools like Bitbucket, they take care of this code and merge it. Not only they merge it, basically, like when you are doing the coding, if you are creating a unit test cases for testing that code, even the unit test cases also get merged. That is one big, very big improvement DevOps has brought in. Second one is the continuous integration. So as soon as you check in the code, just imagine, right? You check in the code, and the code starts getting triggers compilation, and you come to know immediately that your code is compilable or not, or it is conflicting with others, any other third party, or you are not using a correct API or library of your third party tool which is being there. So you are continuous, you are doing the integration immediately, and you are getting feedback from that continuous integration that your code is compilable, it fits into the requirement, and it gives a desired result. Not only that, it gets processed. Basically, it can go through all the automation tools, automation testing tools which we have deployed in the pipeline, where it will go through SAS, DAST, or source code validations as a part of that. Third one is you need to have a very strong deployment automations. You cannot have, if you look at number of people, the number of developers checking in the code, and if you say like, okay, there is a deployment team, the way it used to be in the earlier mode, before DevOps stream comes into picture, deployment was happening manually. That will not sustain. You cannot sustain that practice anymore. You need to have a continuous deployment to see it works or not. And then final discipline is, you ultimately is looking for moving this product to cloud. So the product needs to be product or package, or your functionality, your feature which you have added, developed, needs to be ensured that this whole platform is enabling you for the cloud deployment. Now, cloud deployment may not necessarily that is Azure or AWS or Google Cloud. Even you can have your local cloud, or you can have your on-premises clouds, and that can be deployed here. So what these 4 disciplines helps you in doing, right? What is the business value in this one? One, infrastructure agility. It basically, if you look at it, it's just extending the agile practices which we have in this one. It is perfectly suits our agile practices, like take a small bite, develop, take the feature, develop it in its completeness, deliver it immediately, get feedback from the customer or in our testing, from our testing team, and deliver, add value to the business. And second thing is, you are not anymore depending on IT team to create your environments where you are going to deploy this product. You are not going to wait for someone to create environment for you, deploy it there, test it, and come back. No, it is happening completely automatic, because you are having these tools, basically configuration automation tools, as a part of CI/CD. They will provision the code, they will provision the infrastructure, they will build it, it will deploy. So it makes a whole infrastructure completely agile and faster. Scalable operations, basically, like it's not person dependent anymore, right? Changes are faster, it's getting tested faster, you are seeing what is happening in this this thing, and you are adding value faster, basically. So it's not anymore dependent on individuals to scale it to the next level. And then responsive time to the market, right? Ultimately, what we are developing is where we want everybody wants their product to reach market faster and get the returns on your investments. And this model, DevOps discipline, helps you to achieve that, because everything is going feature by feature, low hanging fruits, and what is the value you are adding faster. So what is the DevOps ecosystem? So what are the tools involved in this thing, and what in at each step, and what are the industry practices? So here, the development team, which is working on and develop with the Eclipse integration, integrated development environment, they are developing it. Then it comes integration. These are the tools available for integration of your code. Most popular are the TeamCity, Jenkins. Nowadays, Travis also is also becoming popular. Bamboo is there. These are the tools basically like use the descriptive languages. You don't need to have a very thorough programming knowledge. Quite easy to adapt yourself. Helps you to create a pipeline workflow in your own development cycle and integration cycle. Development testing teams, testing tools are like Selenium, TestNG, JUnit, JSON basically. These are the very popular testing tools available, which can be easily integrated in your overall workflow pipelines. Again, Jenkins also plays a role here. It can integrate with Selenium very easily. When the code gets deployed, Selenium can ensure that like the test. So what is important in this automation tool testing is basically, it's not just like you want to get code tested basically, or testing gets triggered. What you also want is, if automated test suite, let's say like your sanity test or regression test suite on your product runs, but at the same time there needs to be a feedback loop from here going back to the development team. So if it fails, should it go back or should it proceed for the deployment? That is a call which this automation tools takes basically. So unless there is a very strong feedback loop between TestNG, JUnit or Selenium, it will not be useful. So the configuration which Jenkins helps you to provide is, out of these many test cases, if it passes this number of test cases, then there are showstopper test cases. If only showstopper test case fails, it needs to go back and say that the test certification failed, go back, fix it, then only I'll take it forward. Otherwise, if it has some set of percentage based certification, it goes into the configuration. Next is a configuration manager. We will be covering this thing by taking one of the examples in the next slides. But what is the configuration management is, it revolves around your deployment of your application in UATs, production, or various other environments, and how to make that experience identical and consistent across platforms, irrespective of what is your hardware configuration or irrespective of what is the scalability you are looking into the production. Helm basically like is like packaging, what all needs to be packaged. Helm charts are useful. There are many other tools apart from Helm. Monitoring, App Dynamics, Microsoft OMS. There are other Google tools as well. Security of the infrastructure, basically like you may want to various passwords comes into the picture into whole DevOps cycles. Where to keep those passwords, how the authentication should happen. So security plays a role there, networking, and then the backups. Okay. And then there are, like if you are moving into the cloud, there are then these various platform services available from Azure as well as AWS, like Cache, then Elastic Beanstalk complete platform available, then Azure DB for considering the Azure platform, and then the Azure Containers library. So this is a wider ecosystem DevOps teams or a DevOps engineer traverse through, and believe me, each of the tool, knowledge of each of the tool or expertise in each of tool is a career in the DevOps. So let's enter the world of continuous. So when the DevOps came into picture, and the continuous word start. One second. It start basically like everything needs to be continuous. There cannot be something like I'm waiting for this thing or I'm doing something. No, it needs to be continuous. So moment you commit the code, your CI tools does the merge of your code as well as your test cases. It immediately builds, it needs to build basically the code, integrate it with the third party as well as the other developers who are developing that code. There should not be any wait for anyone, because you should be able to get feedback for whatever the code you are developing, and it should get tested. At least the basic sanity should happen on it. Then it should also able to resolve the conflicts. Something where example is like one developer is expecting a non-zero value in a one particular column in database, whereas the other developer is expecting that value to be null, right? So those type of conflicts, your continuous integration process should resolve, and then ultimately should run the set of automated test cases, which you are achieved by Selenium or TestNG or JUnit, and then it is ready to ship basically. So this cycle is continuous. You ship the product goes out, you're starting on the next code, you again commit. And this happens for every individual. It's not only releasing your code when you're doing this thing. It is basically taking in consideration the code done by your peers, other groups, maybe like one they are working on different modules, or sometimes maybe there are two products separately working, the two development teams working separately on two development models. Let's say, for example, I'll take again the Google Pay example, right? You are making a payment, so you're working on the front end processing, receiving the instruction from the front end, processing it, and the second team is working on risk checking model, where they're checking the balances of the account, checking various other factors that this guy is not, and so there is a banking check basically, like you are not one of those fraudulent person who is doing banking and banned by RBI or government of India. So second team is working on that one. But at the end, when you are doing build, both the modules needs to work in synchronous, right? So this continuous integration helps you to deliver that value continuously, with validation, with process, and no other and quick feedback as well. So this is the continuous integration process. We'll move on to so continuous deployment. So this basically like next stage basically when you ship the product basically, like, and it can be internal shipment or it can be an external shipment, but it is after QA is done. So now let's assume that like you have your QA team, and I'm having a hosted environment where I run my products on my platform itself. For example, right, Google itself is running, or let's say like Microsoft is running Azure platform as a cloud. We all are using, and maybe that's not a better example. Better example could be, let's say like WhatsApp, right? We are using WhatsApp continuously. WhatsApp launches, they are hosting on their own, and they are launching new features every time. So when they test it, they have their own they are testing it in their development shop. Their QA is done, and now the product is going to get into production, and that's where this deployment comes into picture, where from building and after testing, the product needs to be available for your either a certification team in the production, as well as that feature should reach into production as early as possible. And that's where the continuous deployment process coming into the line. So it's like you add a feature, as a developer, and how fast it can reach into production. In order to like achieve this one, basically, right, it completely relies on your infrastructure. Individuals do play a role in between, but this continuous development, which is achieved by DevOps team, delivers that value faster. So it takes the code, it immediately creates a new environment for your code to test. Automated test suites run on it. If everything is good, it passes the expected test cases. It sends a signal, basically the production team, that this new model, this new code is ready to get deployed. And then there are various methods, technologies available there, which takes care of the existing models. Let's say like it is running into the multiple models. It's a scalable model, so you are running multiple services of that model. It withdraws one by one service from the production and start putting this new service into production. It's called like rolling upgrades. There is no downtime. Not everyone, when let's say like WhatsApp, this is the new feature, right? It doesn't become available to everyone in one go. The model gets deployed, certain users start reaching to that module, they start seeing that feature, they start using that feature. No complaints. After a certain time, the infrastructure withdraws that model, puts the new model. And there's a continuous deployment cycle happening for the new models. Every developer is now independently working in this continuous development model. If a feature requires two developers to work together, that feature will be released only after the sign up for that two developers feature gets added. If a feature is self-contained, it gets out immediately in the production. And that's the advantage of continuous deployment. And there is a faster feedback. As you are putting the model right in this one, you're seeing the pulse immediately. The operations team is there monitoring the feature is bombed or it is usable. There is no issue, no performance impact, no other features getting deployed. You are rolling it out to the certain other infrastructures as well, on other servers as well. Comes continuous testing. So this is the one which I mentioned to you earlier. So this is the list, like this is the overall cycle, which we said like developer checks in the code, continuous integration, continuous deployment, and here are the various testing. Even before deploy the testing, these are type of testings happens which are achieved by DevOps continuous automation, check marks, severity, white source. If anything issues there, basically like in this testing, it will raise a defect automatically. These are all integrated, no manual intervention required. Jira tickets gets raised, it comes back to you basically as a developer to fix them. The certain test cannot be carried out on the source code. It needs, product needs to be deployed on certain system, and that's where like it gets deployed automatically on a target system. And then your automated test suite, functional test suites, which is written in JSON or JUnit, Selenium gets tested and moves into this one. And then finally, there is your dynamic testing, which happens with the help of SonarQube. Maybe you'll find me running a little faster, but I know like clock is also ticking. So so it's a whole cycle, the continuous world which we saw. I can take a couple of questions here, Christo, because before we move on to a special section, we can go and have a couple of questions until now.
Sure, Arvind. So we have a couple of questions for you. So the first question is about version control. So the question is, which version control tools are available in the market? And if you can name them.
Okay. So in the open, right now, like SVN, Bitbucket are the very popular tools right now in the market. Bitbucket is popular, as well as Git is as such is useful as well. Git is integrated with Bitbucket, and therefore you have a lot of advantages having Bitbucket and Git as part of your version control and development cycle. Reason is Git facilitates basically a lot of parallel development, not within organization but from outside organizations as well. And Bitbucket allows you to dynamic merge not only code, test cases, but even it helps you to generate the artifacts.
Thank you very much, Arvind. The next question we have is around CI/CD, and the question is, which cloud is best for CI/CD implementation?
Okay, so there is no as such basically we can say like which cloud is best. Amazon, Google, There are like private operators as well having their clouds, as Microsoft Azure. These are the three main players in the cloud, and they're competing with each other very heavily by bringing in. It's not just like you are making cloud available for others offering space, but unless you have orchestration system, orchestration components developed way faster and bring in to make your experience easy, that cloud is not going to be easy. So I tell you the example, right? Why the reason why we are moving to cloud is if I deploy my component right now, if I run it on my own premises, let's say like I have a server and I'm deploying my app on my server, I have to develop all the things for that one. I have to build the whole infrastructure. I have to develop monitoring requirements. So I have to buy monitoring tools. I have to ensure that like there is a disaster recovery. First thing is high availability at the local site itself. So again, go into the market, buy the tools, deploy it on my local infrastructure, and make it high available. Build the disaster recovery sites, so it needs to be a different location, different data center, and you just imagine the mammoth work, resources, licenses, hardware, infrastructure required to do it. Now if I move to cloud, I expect cloud to offer me these services as a part of that offering itself. What I should worry about is my product running in that cloud. I expect cloud to provide integrated monitoring. I expect cloud to provide integrated local failure capabilities, high availability, local high availability if the service goes down, or if my pod goes down, Kubernetes pod goes down, it should spin off the new pod immediately. Or if my VM goes down, it should spin off my new VM. And at the same time, if local servers or data center goes down of that cloud service provider, I expect seamlessly that whole cloud to bring up disaster website and my application are being available there. That's on the infrastructure side. So at the same time, I expect my cloud to take care of my firewall security as well. No intrusions basically. So I have the firewall covering untoward hackers accessing and attacking my applications on the cloud. They should take care of that. I expect them to take care of my authorizations, user validations, scalability, dynamic scalability. So these are the features which we generally look for in a cloud. And then if it suits your requirement, what you're trying to build, that cloud is suited for you. For Finastra, we have moved to Azure because we had a corporate tie-up with them, and Microsoft is working with us to take us our Fusion Fabric.cloud, which is a financial products app store similar to Google Play as well as Apple's App Store. So we are coming up with that as a store. It's already live. So we tied up with them, and they're developing certain features, certain capabilities for our FFDC platform to make this seamless experience. So it's not everything one is good or bad. What suits your requirement, you should go for that cloud.
Thanks, Arvind. We have a couple of questions here. Is it okay if you want?
Yeah, let's take one question, because I do want to cover like a couple of key elements of DevOps, and I know that we are running out of time. So one question.
Sure. Okay, so this question is from Vishnu, and his question is, if he's creating a software application full of package code and deploying in Docker container, then how can he maintain and monitor all the things for the security? That is the first bit. And the second bit of the question is, and which operations can he do at that time if the deployment is not done properly?
Perfect. So I think I have a slides. So we'll cover that, Vishnu, in a couple of minutes.
Okay. All right. So we'll park the questions for the end of the session, and Arvind, you can continue.
Sure. And I will respond to the questions even after the session is over. We'll take them on the emails or chat.
Sure.
Okay. So configuration management. So what is the configuration management, right? So you build the app, you develop, deployed, tested, and you are sending it to the data center to deploy it in the production or UATs. the configuration management is the responsible team which deploys your app, deploys the changes into the production. What they do is they are responsible. Their job is basically to manage multiple servers. As I said, keep an eye on infrastructure utilization. If the CPU utilization, memory, or storage utilization is going up and down, accordingly, like the increase their server capacities, and continuously keep on syncing with development teams to update their run books and validate it with that. Means, like, for example, if this error happens, what action operations should take it. That is their job of configuration management. But with the traditional way, there is a maze too, right? Over the period, you don't have identical servers running. Why? Because if an operator is working on a product for a long time, he develops some capabilities and expertise, and he knows basically what he's doing. Either he's not documenting those things, he's just taking care of, like, he experienced an issue in one platform or one server, he handles that issue there, and then he's not supposed to touch the other servers unless there is a green zone, and he waits for the weekend. And then if that whole incident is not documented well, corrective measures are not planned, then you are running complete unidentical servers in your production. And when some issue happens, you are, like, completely confused why it is happening on one server and why it is not happening on the other server. So that it creates a complete mess. It revolves around your expertise, local expertise, and individuals. To avoid this one, you heard that terminology, right? Quality terminology, like CMM level 5, CMM level 6, ISO standards. What they told us, basically document these things, document the process, follow those processes, stick to those processes, document everything. But then how much documentation? And when the issue happens, do you have really a time to look into those documentation to do a recovery? So this semi-automation, which is mostly dependent on process, is it good enough in the current environment when business is expecting your feature to go into production as early as possible? You delay by a day, by that time your competitor launches that feature and take away the crowd, take away the followers, take away the users from you. You don't want to be behind this thing, right? And therefore, in this fast moving environments, you want your features to reach into production as early as possible, as fast as possible. Plus, at the same time, there should not be any issues also. There should not be defects in that issue or the feature which you're launching. And that's where this configuration management came up with the different new tools like Ansible, Shape, Puppet, which are orchestrating this touchless operation and agentless operations. These are very popular tool in the market. So we'll cover one of the tools. In Finastra, we are using Ansible, but Shape and Puppet are equally powerful and useful. So as I said, like, deployment strategies, like you are deploying your application in multiple environments. It can be on your premises itself. Certain companies are having their own data centers like Google or Microsoft, and their products are running on that one. Even Finastra also having their own data center, and the products are getting deployed in their on their premises, and customers are accessing those products. Second one is hosted. So second one is a hosted, where we are hosting that product for our customers, but on a dedicated servers. It's not shared with others. It's basically like data security, data. There is a compliance requirements, regulatory requirements in the banking domain that no other bank should see the data which they are processing, see the transactions they are processing. So that is a hosted. That is a SaaS, basically, like where you are having one instance running and everyone is accessing that one software as a service, which you might have come across. And then the cloud. And when I say cloud, so even SaaS and hosted can be considered as a cloud, but I will not call them as, or we don't call them as a cloud, because unless and until you use the cloud features which we discussed earlier, all the capabilities of the cloud monitoring, tracking, authentication, security, disaster recovery, high availability, scalability are not taken care of, it will not be considered as the product being deployed on cloud. So the cycle product goes through SIT, UAT, and production. What you expect though here is in this all these three, when the product is getting deployed here, you don't want basically to deploy these products in a different way every time. So it should be same, right? Means like you should be using the same document, same process. That then only you will come to know if your deployment is flawless or not. You deploy it here, you come across an issues, you're resolving it, you're applying your updating your configuration management playbooks, runbooks. You're doing it in UAT. You're again doing the same thing. It should run that way. And only when there are no flaws in these two processes, someone is approving that product deployment process as well as your software to go into production and how do we achieve this? Because SIT is generally a small environment, right? You are not really looking at having the high number of CPUs or high availability, or all the monitoring which is there in production is not available in SIT. Similarly, like UAT might be a copy of production, but again, it varies in the size. It's a little different, smaller. It might not have all the disaster recovery website for the disaster recovery configuration in UAT. And then the production also the same thing, right? That's where Ansible, Chef, and Puppet comes into picture. They allows you to create a configuration and you can pass on those variables to those configuration files as a data. So you have one playbook, one deployment playbook, role defined to deploy the software, and you just have to pass on the variables and it creates this thing. For example, in SIT, if I'm provisioning a VM to deploy my product, I want to create one, maybe a 2 CPU environment with 2 GB and let's say 10 gigs storage. I want JBoss to be my middleware, and I want application to be configured only one single service each for everything. My playbook will have the same thing to create all these things, okay? And you are just passing a variable saying that I want one server with 2 CPUs. That becomes your data which you are passing to this configuration tools it's creating. Same playbook, you are using it in UAT, but there, what is the difference? You are passing those variables into UAT are different, so you are creating that environment there. If you are setting that my UAT needs to be cluster, and there is a cluster playbook which comes into the picture, and then the customer playbook and role which you are defined, coded in the Ansible, it will create a cluster. If you say no cluster, it will not create a cluster. You said no DR, it will not create. So a playbook written at the SIT level, completely reusable until then. So now, when a new feature is launched in the application, for example, it requires a new MQ to be created on the platform as a part of a deployment process, your playbook will add that into this at the SIT level. You are updating that playbook, it gets tested in SIT, it moves into UAT and production. Tomorrow you change the middleware saying that I don't want JBoss, I want WebSphere. You are creating a new playbook, adding a WebSphere role, playbook calling WebSphere role instead of JBoss role. You are doing it in SIT, you are using the same playbook in UAT, and same playbook goes into production. That means nothing goes from SIT to production without testing, and it happens fast because it's completely tested. You are having a error handling mechanism. You are having a quick feedback because of this configuration management tools. How it benefits, right? So let's take the example of new environment provisioning, right? So for example, you are working in your college and you are developing your project and you need new server. I'm sure like this must be your flow right now as well, right? You are asking your DevOps team basically, I need a new environment with this is the specs. They contact IT ops team, they check hardware availability, they check licenses, it requires manager's approval, and then somebody creates that environment VM. Then IT team contacts you for like what should be the hardware configuration and what softwares you need, how you want that software to be configured. Then you are doing that one. Okay, I want JBoss, I want WebSphere, I want Oracle, and I want JDBC basically to connect to this one, right? You are giving those ones. They again develop that. And then at the end, you are develop your application. You are actually deploying the application, configuring the scripts to connect to MQ, connect to database, and that's how your environment is ready to use. If you look at it, the time it takes to get this one environment deployed, and it's not just Redac or any other institute basically, it's still happening in the organization which are traditionally driven, not the modern organizations. It takes hours to days to get this one. There are multiple dependencies as you see. Now you take an example of using, let's say like a playbooks, right? Here you are already, your DevOps teams have developed a playbook to provision an environment. So that script already has basically like how a VM can be popped up. What are the requirements that playbook requires as a requirements? So you have a variable file. You just submit a request in the variable file saying that I need this VM with those many things, 2 CPUs, 10 GB RAM, and 100 GB storage for this one. That playbook comes into picture, it triggers. As soon as it finishes the job, it will take the next task. What are the middleware you are looking for? Your data file is saying that I'm looking for from your questionnaire, which you have filled in, saying that I need JBoss, I need Oracle. It will call those roles, install those ones immediately. It will kick it off one after another automatically. These are like, and then at the end, basically, like you might have some custom variables for your deployment because it's your development or it's a QA, and depending on those variables, your environment gets ready. It's just basically like in minutes, without any dependency, with available playbooks, environments gets created using these new tools, configuration tools. Let's take the one release engineering related use case. So Ansible also has to create a complete end-to-end automation workflow. It's called Ansible Tower, AWX, which does the orchestration of the small elements, because you will have a lot of playbooks written for various tasks to be taken care of, right? So our workflow case here is like provisioning of virtual machines for your deployment of third-party softwares, which are not the ones which you are developing yourself, having done some configuration of on those third-party middleware, and then ensure that there are environment boundaries, means one should not step into the other role basically, so that then there should not be conflicts between the responsibilities. So this is how the so these are basically like when AWX, this is a dashboard view, actual practical dashboard view. This is how you will see in the AWX dashboard. Once you click right, Ansible, right, you are passing a variable saying that I am looking for a development environment to be created using Ansible, and you are providing all the details variables system. Ansible kicks in, it provisions the environment. It looks into its inventory source basically in the available infrastructure to carve out an environment for you, create an VM for you, looks into add the storage to that VM, looks for the prerequisites. What are the prerequisites before I create this environment? And that is something which you already given to this workflow, that what are my prerequisites to create it. It looks into that one, and it automatically aligns those prerequisites for your application. For example, as a prerequisite, I had given that I need Oracle database, I need JBoss as well as WebSphere, I need ActiveMQ. Okay, these are the 3 things I need basically for my application and product to work. It will deploy for these development environments these 3 things. It will create after that, like it will create a Oracle database user. It will install, basically create a schemas for you depending on a requirement. It can be 1 schema, 2 schemas for your product, multiple schemas. It will configure JBoss application server to connect to this database. And if you have further integration, basically like authentication, single sign-on, or other custom configurations which you are defined, will do it. It moves basically when the previous task becomes green, then only it moves it. There are ways basically like if you say like this fails, you can give a signal saying that if this fails, it becomes red, but do I want to proceed further or should I hold it here? So for example, here it says I failed basically. So on failure, there could be another task saying that try to recreate maybe IBM MQ instead of active MQ is not compatible with me. Or you can have a task here, you raise an alert, let the developers know that active MQ creation has failed. So this basically the workflows of AWS dashboard allows you to create this, automate these workflows. You can write all these jobs, all these playbooks and rules in Ansible independently. You don't have to wait for someone else to do it. So you can say that like right now this operation of JBoss or WebSphere installation is manual. Fine, I can start automation of this one. I can start automation of this one, and I can keep on adding this automation later on in parallel. That allows you not to try to do everything in one go, but you can start in the gradual process. So this is about configuration management, an important part of the DevOps roles. DevOps engineers writes these automations in Python or Ansible itself has its own scripting, which is very easy and descriptive language. We'll cover containers, which is important. I know we are running short of it. So
yeah, Arvind, we will have to speed up a bit. We'll have to speed up a bit.
Yeah, yes. So containers basically, right? So what is the containers basically, right? So why do we need containers? So if you look at it, right, the earlier mechanism, right, when we are deploying the applications, we already moved away from actual dedicated servers for each of the app. We already came to the era of virtual machines. Means like you have a big server and we're using the hypervisor. We are creating multiple VMs having their own OS systems, and your app can be running on it. So one hardware can host multiple applications. That is a virtual machines infrastructure. Whereas if you look at the containers infrastructure, here it basically allows you to take it further, to make it basically more granular level, to maximize the use of your infrastructure, as well as within infrastructure also on a VM you can have multiple applications running without having a dependency on each other. It facilitates basically no dependency on your development language you are using. It facilitates basically you can have multiple versions of the same app you can run on that one, as long as you're sharing similar features of your operating system. It's like basically like I will say, like if you see these containers which are moving on the trucks, right? We don't know basically what that container is containing, but at the same time, the same containers you can see it on the shipyard. Those containers are being shipped by aeroplanes, cargo airplanes. The same containers you see loaded on a truck. Means what it is, it's that container is oblivious of what operating system, what infrastructure you are running. It's basically doing the job which is intended to do. It has no conflict with it takes care of it's basically the image is completely immutable in this case using the containers. It's reduced the management of your infrastructures as well, because now if you are running the multiple applications versions on the same containers, you are scaling your applications. They are if it's something goes wrong with that one, your serviceability is not going down because the multiple versions are available. That one containers can go down, but the second container is available, can be popped up immediately for user services. So what containers work on? So basic tenet of a container is image, right? Means now images, your application, when it is built, it needs to be converted into image. It can be a Docker image, which can be stored in your local repository. Now these images can be split into depending on your application. So containers is more suitable for your microservices. You have monolith apps. Let's say if I develop a banking app, it does everything, and it's a big anything which I have to change, I have to change in this code. Build this big app. We call it as a monolith basically. The era is now to split this app into multiple small services called microservices. Each feature should be self-contained, working end to end, taking some specific input and giving you a specific output. It should be able to attach to the various services your infrastructure is offering, the cloud services offering, which I mentioned. So there should be a probes attached to that one, and you get attached. So you are building an image of your product. It can be of any image basically, like you can have your operating system image you require. You can have an image of your runtime environment. You can have an image of your multiple models. It goes in together. It moves into the image registry, and then you can build a container of the images required images. If you see here in this app container, these are like different microservices which which are built and can go into one container. Now, going back to the question basically earlier asked, right? What are the tenets of a container before we take into cloud, right? First thing is like your container needs to be it is preferred to be one object end to end. It should be a self-contained. It needs to handle basically all the error conditions. You need to have a very, very good model basically to provide the feedback. It's called observability property. It should be able to give the feedback what happens in your container. It shouldn't be the case like you send a request to a container and container is not responding and there is an unknown error, because then the Kubernetes cluster which it is hosted in will not understand what to do container. Should I scrap the container? Should I spin off the new container? It will not have that. Plus, it needs to have a layer adaptability to communicate with monitoring systems, security system, and scalability models which your infrastructure provides. It should be able to take care of your authorization between container to container, because not all images will put into one container. So you need to understand the request which you are receiving from another container in the cloud is an authorized request coming from that one. So you need to have those probes exposed to do all these things. Now, one container, the role of orchestration is very, very important. And the principles of these orchestrations are like scalability, resiliency, and extensibility. In the sense, like when you have one container, it's very easy to handle. But if you have multiple containers, you need to be able to manage those multiple containers together. And therefore, that's where the orchestration comes into picture. These are the various elements of the orchestration. And these elements, these properties, when you are building your container, when you are designing your container as well as your microservice image, you need to consider these elements of your orchestration. As I mentioned, scaling, networking capabilities, service discovery. Like if your component, as taking the Google Pay example, right? If you're receiving too much of services and your container is not able to handle this volume, your service store should be able to spin off new container immediately to take new traffic on its own and process those transactions. It should have the probes to do the health monitoring. It should have the capability to do the app upgrades. You're launching a new feature, it should be able to do that one. And it should also have a failover. What are the prerequisites for developers? They should be able to deploy multiple containers for the within the same application versions. Should have the capability to scale the your application capability. You can, if you are an example of scalability is, let's say like if you are using a sequence number logic and that sequence number logic is stick to a database, and that response from that database is being managed and only derived by one container, then you cannot scale your application. So you need to think of what can I use basically to handle this sequence number logic to identify my transactions uniquely, even if I spin off 2 containers or 3 containers. So those are the things basically you should look for. There are advantages for IT administrators. These containers are highly flexible. You don't have to bring down the service. You can spin off new containers immediately within the pod. We'll just quickly touch like how this containers works, and that's where like going back to this another question, basically, this is the deployment architecture of containers. Kubernetes is a very popular orchestrator here. There are a lot of Kubernetes versions available right now because Microsoft had chosen Kubernetes and they started developing their own Kubernetes features. Amazon also is doing the same thing, and Google has also started adopting another Kubernetes services. So if you see here, there are master nodes which control the traffic which is coming from the external world. If you see here, these are the master nodes which controls where the work should be gone, basically. So there are worker nodes depending on the volume you are processing. Think of a Google Pay, and you can think of like how many worker nodes they must be having. And there are master nodes basically which are controlling who should be this transaction be sent. And if you see here at the bottom, like these are the keywords for authentication at various nodes. Means this master node needs to authenticate, ensure that I'm connecting to the perfect and correct worker node through this authentication model. These are the security models to take care of the security of these worker nodes. And then these are networking basically nodes which are connecting these nodes each other. These nodes can talk to each other not through internally. Master nodes communicate, handles this traffic communication between them. For example, pod 1 is, let's say, like it's processing risk acceptance, liquidity risk, basically. Now, this risk liquidity model, this container which is handling that service is busy here, and this busy here. It can let the master node know immediately that I have enough load to handle it. I'm looking for someone else to take care of it. And it identifies that second module probably will have availability of that one, and it hands over it to the second module, basically. So that's how it works. Database being a single source of truth generally can be in one of the modules or separately. It is database is not containerized many times, but for certain functions, if it is a small database function it is doing internally, you can still host a database within the within your Kubernetes cluster as a container, so that it can expedite certain things like your need performance to be of higher grade. You can put the database in that one. Or there are very small operations, database size is not growing, you're not maintaining transactions there, but you are maintaining metadata there, then you can have it in there. So that's how these clusters are different. These are all like VMs clusters, these provisions. So Ansible or Puppet or Chef can spin off these master nodes as well as this one, because ultimately these are VMs and it's part of provisioning. If the volume increases, they say like they see that like there is a more requirement, those scripts can spin off new master nodes, new worker nodes, put the containers in it and work on it. So this is a deployment architecture kind of. So you have containers, you have pods, nodes, worker nodes, master nodes, and then this is basically your load balancing service where the request should go. So how do you can get your hands on it basically? You can build your containers very easily. You can look for mini cubes using the cube CLI, cube control. Develop your code very easily. Playbooks and roles available for you to develop and put your small utility. You can just write a simple hello world program and put it into cube control yourself. You can build your own control Docker image as well as put it into a Docker container and use the cube control to put into Kubernetes cluster. You can take a new step basically, like put it in the cloud. Various playgrounds available in Amazon, Azure, as well as Google, free subscriptions for students, and you can use that one. You can take advantage of these managed services. For example, Azure Container Services like AKS is GA right now. It's free, and you can actually connect this Hello World program to see how the managed services works in cloud for anything. So this we covered configuration management and this thing. The biggest part is now the pipeline. How do I orchestrate, right? And what is the success criteria as such completely for DevOps as well. It's defined by pipeline. So as I explained earlier, right, your journey of your automation starts from the environment, like provide automation as much as possible to development, extend that automation to your QA, take it to UAT and production. You can start automating the things which are required for your product build, like then take it to middleware, operating system, networking, storage. All these automation stacks you can start automating in parallel. This is towards your end when the deployments are happening. If this all developments can be happening in parallel, and if any development needs to be a metrics driven, unless like you measure the result of your automation and compare it with your previous results, it will not call it as a success. So it is, so your pipeline, containers, and civil configuration, CI/CD should give you improved throughput and stability. You should be able to measure it every time. Number of cycle times, number of defects, all this can be measured, and that forms your success criteria. General simple example of a pipeline is you're doing a pull request into master. As I said, like Git repo does that. Like then you are doing automated builds. After your build is done, image is formed. You are doing a Docker build, upload the target, register that image, publish the artifacts. And artifacts here is the execution results, test results, which will allow you to take your image into the production before it goes into production. In these steps, you are doing coding, creating Docker files, Kubernetes configuration files, Helm charts for deployment. Here, like you are doing all the testing using various automated tools, code coverage. Containerize, you are doing the Docker build, do the container testing, and when you are going basically like just releasing the product, go into container registry, and here is basically when it gets deployed into the Kubernetes cluster. It can be Amazon, it can be Azure, or it can be Google clusters, where you are, these environment variables define what type of deployment you want. As I explained earlier, like single server, double server, multiple services, single service, multiple authentication, dual authentication, SSO, all these are defined by your environment variables. Monitoring configuration is also done by these environment variables. A quick view at how the Azure pipeline looks like. So this is from our development stream. So if you're looking at all these are like various automation done at every stage. When that step is passed, it basically is, on the dashboard it says that it's passed. If you want to bypass a step here, like if this step is failed here, but your condition is given, even if this step fails, I still want to go ahead and complete the remaining of the parts of that cycle, that pipeline. It does that. If you want that, if that step should not progress, it will stop there, that execution process. When you are developing your pipeline components and you want to test it, you can decide basically to bypass certain cycles as well. So for example, I'm developing a pipeline component for Oracle deployment, right? So or Oracle configuration. So I don't want to rely on JBoss deployment. So you can bypass the steps here and go to the last stage basically of testing. So this is how pipeline looks like for one of our applications. So you can control in Azure environments, releases, there are library of the task, and then there are various tasks which ultimately are becoming part of your pipeline. So who is a DevOps engineer, right? Ultimately, right? So DevOps engineer is the one who are the successful DevOps engineers. These are the one who are looking for like, it's a traditional operation, right? Going on by earlier, we used to call system administrators, developers, and they only knew their things. None of them others knew the things. And there are certain patterns developed over the years that's how it has to be done. You cannot do it differently. First thing is, as a DevOps engineer, our behavior needs to be like, you need to have a clarity. Challenge the assumption basically like this is how it has to be done. No, you should be able to say that I can do it differently. I can use any other tool. And in this DevOps world right now, take any organization, even in Finastra also, you don't have to stick to these tools and technologies which I mentioned. Even if we are developing Ansible and someone comes up and says that I want to use Chef because I'm seeing these advantages, and you are allowed to take advantage of Chef as well. So basically, like, you challenge, go for these ones, avoid gold plating, is trying to show that in a better way. Objective here is get the job done, and get the job done with quality and efficiency. Avoid patching. Don't do like you come across a defect, you patch it there only. No, take a systematic approach. Go into the, like, you encounter a problem in production, don't patch it there. Come back to SITA. Change your charts, change your playbook roles, and take it from there. So that's how these are the important behaviors of DevOps engineers. What are the roles available? So DevOps, we are building and we are enabling our organizations to move faster, reliably, increase their efficiency. TakeOps is the role basically which bridges the gap between cloud ops. So what is the cloud op, right? Which I said, right? They are the expertise in only cloud. What they are familiar with, they are not familiar with your app, but they are familiar with the complete ecosystem which is required by your cloud. Means what is the Azure is providing, what is the Amazon is providing, monitoring, tracking, authentication, RBAC, all those things are the cloud ops. And TakeOps plays a role between the two. They are the implementation guys who works on the product deployments then for the enterprise products and works there. So these are the roles which are fairly integrated with each other with the same knowledge base. As I said, the technologies which we had shown you earlier is a career itself. So the one who automates and manages is the DevOps engineer. I hope I'm able to cover all these terms which we had at the beginning and helps you to become a DevOps engineer. So you want to take questions now, or should we? How do you want to propose?
Sorry, I was talking on mute. Arvind, we are on the time. So what I'll suggest is I can probably share my email ID with the students in the chat, and we can take the students and answer it to them, because we are already at 12:32.
Sure. So guys, I have everyone, I have this reading material also associated here. It has everything which we, irrespective of the DevOps functions here, the reading material. Over to you, Madhuri, for campus hiring overview.
I think Madhuri has some technical difficulties, so I will just cover this up.
Sure.
Arvind, if you can just move to the next slide. So guys, I hope that you had a very insightful session in terms of overall in terms of DevOps, and I hope that you get to know more in terms of the different terminologies. On anybody who is actually probably working or doing something on the DevOps bit, I think it was an insightful session. Before we end, we thought we would share the experience, and a couple of pictures that you can see on the screen are from last year, the recruitment pre-placement talk, and I think these are all the new joiners from last year who got shortlisted. So anybody who joins as a part of the campus hiring batch, we call them a FinStart batch, and we have a FinStart program for them, which is probably a 2-year program, right? And there are various experiences that we give the FinStarters with us, right? From ranging from campus to corporate sessions, functional trainings, boot camp sessions specifically catering to the technology needs with respect to which product you will be working for. We have various sessions which covers the culture and mission workshops, CSR initiatives. We have hour of code activities that they go through. If you all get a chance, you can check out this website called as fusionfabric.cloud, which is the platform that Arvind was mentioning in one of his slides. We have regular coaching and mentoring sessions for all the FinStart people. And definitely a lot of awareness about social learning and sharing that happens through various platforms. We have a global hackathon which happens every year in the month of at the year end, usually in the month of December, which all the students across various partner colleges can participate with. So as I said, you can go visit this website called as fusionfabric.cloud. You will find a lot of our open APIs, open APIs there, and in case you want to build something, partner with any of the people, have some apps created, you can explore that option as well. So in a nutshell, we ensure that we have an open culture, and we let the fin starters experience it through the various platforms available within the organization. So that's in a nutshell, guys, about today. Thank you very much. We're really sorry. Probably we're just over and above by 5 minutes, but I hope you had an insightful session. What I will do right now is I will just put my email ID in the chat section so that you have any questions post the session. Also, you can reach out to us. The soft copy of this presentation will be shared with the IACSD team, and you can, probably they will share it with you for reference. As you could see in this, last slide with Arvind, there are some content reading material, some videos that you could check it out. These are all the material. Arvind, correct me if I'm wrong, that we are also using internally at Finastra. So I have just put my email ID. I already have around 6 questions, which I will be sharing it with Arvind, and will be responding them to the IACSD team, and they could probably revert those answers to you guys. But again, a big thank you to Keshav sir for inviting us, and I hope that we have this partnership. Also, not missing the point that we have a great alumni from CDAC at Finastra. Many of who who started as freshers, like 23 years back, and who have reached director level. So we have people, your alumni, who are a great part of Finastra, and we look forward to a growing association with CDAC in the years to come. And special thanks to Arvind for taking this time out and sharing the knowledge with the students, and I hope this has been insightful for all of them. All right, Keshav, so you there?
No, he's in a meeting. Actually,
Okay.
I'm Rohit. Okay, hi. Thank you, Arvind sir. Thank you, Christo, for joining the webinar and conducting the webinar. Thank you, all of you and your team, for conducting this wonderful webinar from our CDAC students, and hope they have enjoyed your session.
Thank you very much. Thank you very much. Have a good day.
Unfortunately, yes. And we'll definitely answer all the questions. I got few of them, and by the end of the day you will get feedback from me.
Yes. Sure. Thank you very much, and have a good day. Take care. Bye-bye.